Hello everyone, welcome to one more FAtiMA-Toolkit tutorial video. As you've seen or as you could have seen, FAtiMA-Toolkit is also used in the Artificial Intelligence in Games course. Over there we made a short tutorial guide or a short exercise so that students could get used to the toolkit and learn a little bit about each component. And I thought it would be a good idea not only to share this guide, but also make this video to essentially show how to do each of the exercises. So if you want to learn FAtiMA-Toolkit, I suggest you try to do it on your own and then look at this video to see the solution. All right, so in order to start, we need two different things. We need FAtiMA-Toolkit itself, which means we need to use the authoring tool. And then we need to use the FAtiMA Starter Kit Unity project, okay? So once you've downloaded this, we now have FAtiMA-Toolkit and also a Unity project that contains a game where you're able to edit its characters, okay? Unity is a game engine. I hope you're familiar with it. Essentially, it allows us to create games, and within this project, there are two different scenes, which is two different, I guess, games. We have a single character scene where essentially the player has the option of picking two characters, and another one which is whose components are two different. Sorry about that. Two different characters. Okay. So let's focus on this single character scene, and let's try to follow the guide, okay? So essentially, the first thing that we talk about in this guide, which I hope you're looking at, is not only do we need to have these two tools. The first one is a Windows Form application, which means it's a software tool, so you need to run it in your computer. Unfortunately, for now, it is only available to Windows, although I haven't really tested it fully. But it might be able to be run either on Linux or on Apple computers using some programs, but I'm not sure. You need to look into it. Okay, but moving on. The first thing is just to explore the code provided here in Unity. Essentially, we have these C# classes, and right now we only have one of them called the manager script, which essentially manages everything related to the algorithm that's being run so that the game functions, okay? And while this code is quite well documented, so you can take a look and eventually edit it. If you want to edit stuff out, be my guest, okay? And we have these comments explaining each one of these essentially variables. And then what you do here in Unity is that for its start function, you can see that he loads two different files. The storage file and the IAT or scenario file, like I call them. He calls these two methods the getStorage method and the getScenario method, okay? These files, you can see them here in streaming assets, single character. You'll see that there is a scenario and the storage file. And these are JSON files, which means it has information coded as JSON. And if you open them, you can see them either using Notepad++ or Notepad, the normal Notepad. You'll see that we have here some information like scenario name, it's this example, a description, the dialogues available in the scenario, the characters, and in the storage, the same thing, but right now it's applied to the components, okay? So the idea is simple, is that you store, using FAtiMA-Toolkit, you edit these JSON files, and then the game is able to pick up on them. So it is able to read them and then process them, okay? But now, if we were to edit these files like this manually, it will be like really ugly, I guess. And so what we do is that we want to use the toolkit here. You'll go to here to File, Open, and then if you search for your directory, so assets, streaming assets, single character, and then you open the scenario.json, and you do the same thing for the cognitive files, storage JSON, which is the storage JSON, okay? And so now you have what I call the scenario essentially loaded, where you can see here that you have the example, you have the description, like you just saw in the JSON files, and then we have the characters here, we have some dialogues, If you press on top a character, you will see that it enters this character tab. And the character has a name, a body, a voice, has its emotional state, the knowledge base, the autobiographic memory, and the goals, right? Over there, we can see other tabs, such as the dialogues, the cognitive rules, with the emotional appraisal, emotional decision, social importance, and CK. We have a world model, we have a simulator, and we have a web API, okay? We also have another tools here, but I'll talk about them later, okay? We also have the About window, which tells us a little bit about the contributions of this toolkit. These are all the people that work in the toolkit, and this order is not by, it's just a random order, honestly. Okay, so, yeah. All right, so let's look at the guide once again. I know that I've skipped a little bit. So I talk a little bit about the characters, so if you want, you can change the characters within the game, right? We've just explored the manager script and the start methods. And I talk a little bit about this, but essentially here in the guide, you'll see that there are some links. The idea is that, for instance, I give you a task and you can learn more about it here in the FAtiMA-Toolkit official website. For instance, when we are going to add belief, we have to follow this syntax over here that I've explained here in the website. So you can read this, read more about it, and then try to make or implement the exercise, okay? So regarding that, let's look at, once again, I was in the right page, right? Let's look at the lecture. We are over here. During this lecture, we'll use the guide and the website together. The guide will tell you what to do, and the website will provide further details on how to implement it, okay? So let's open the toolkit. Let's open the scenario like we just did. So we just go to File, Open, and find the scenario file, and do the same for the cognitive rule file, okay? And now you can see that we have two different characters, right? Like I said before. We have Charlie and the player. And we know that under the character tab, in the knowledge base, it has 3 different beliefs, and player has other 2 different beliefs, okay? These beliefs right now are only related to the dialogues, okay? So for now, let's ignore them, okay? And what I've written in the guide is that we need to add add more beliefs to the knowledge base of the agents. You will need to respect the syntax, okay? So the syntax is simple. We have symbols that represent constant entities such as Sam, A1 table. We have variables which are within squared brackets, okay? And then we have composed names such as likes Amy's chocolate or has Sam dice or something like this, okay? And for beliefs, we need to have a composed name, which means we need parentheses somewhere here, and we might want to use variables or not. But let's do something like I told you to do, which is Charlie has $5 with him. Okay. So let's create this has money. Let's say there's a has money variable or a belief. And so let's add it. Okay. As you can see, the belief name starts as a complex name or a composed name, and you need to keep this format. Okay. But you can just erase it and go like has money, and then the value, let's go like 5. Okay. And this is pretty liberal. You can put almost anything here. You can write has money or has money 5 equals true, something like this. Okay, you could have done like has money 5 and this equals true. The objective here is that you want to be you want to make sure that you are consistent within the scenario. Okay, so it doesn't really matter what you write here as long as you use it throughout the scenario, all right? It makes sense. I like more the other one that I had where he has money of 5, okay? So let's update this, okay? So right now he has money 5. Charlie has money 5, okay. What about the player? Well, the player has the floor. I'll talk about this later, but essentially, well, I'll talk about this later, but let's go. Now, the player is hungry. I can describe this once again in several different ways. I can see that he has even a goal of eating, for instance. But let's not do that. Let's simplify this thing. And so let's say is hungry, which is true. Okay. All right, so I'll add this. Is hungry true? Okay. All right, so now we have a knowledge base, right? And now we want to do something with these new beliefs that we added, right? We don't just add beliefs just because, okay? And so we have the money. And let's try to do an action rule. So we'll go here to the cognitive rules and to the emotional decision making. This is where the rules are written, the action rules are written. So in order for the agent to do an action, he must have this action here, okay? And let's add a new action, and it could be something like offer, okay? And let's say that Charlie is able to offer money to the player, okay? Okay, cool. So let's add this action here. He has this action, priority 1, and there's no condition so far. So when we added an action, how do we see that this action is enabled? Well, you can, number one, remember to save everything, okay? And then let's go here to the simulator and see what happens in the scenario, okay? So when I start playing, you'll see that Charlie is performing to the player offer, and player is also performing to the player the action offer. So this is interesting because the player is essentially making the action himself, to himself, I guess. And the cool thing about the simulator is that you can play as one of the characters, right? So now I'm playing as Charlie, and I can see here that I can either say to the player good afternoon, which is another action, okay? Or I can offer to the player, I can do the offer action, right? Okay. And the way the simulator works, it's simple. He goes around and asks each character to do an action, and they will return it if they're able to do an action or not. Essentially, if I had other characters, you would ask every single character if they wanted to do an action, right? And the cool thing is that I can also inspect the knowledge base of each one to see if the beliefs were updated or not, or if anything changed. And I can also take a look at the emotional state. Okay. Okay. So let's go back to our rule and let's add a condition, right? It doesn't make sense for him to offer, let's say that this offers money if he has no money, right? So has money bigger than 5, right? So this makes sense. Maybe not bigger than 5, but maybe bigger than 2. All right, save. Let's save this. And now let's go to the simulator and see what happens. Well, now I have the option to offer to the player, but I bet that the player does not offer me back, right? So if I start and I can see the actions of the player, you'll see that I still don't have, actually I didn't change this, but I need essentially to change the action, right? So because the player has no money, that condition is not being accepted. So he's not being able to execute that action, right? Because he doesn't fit the condition, okay? Cool. So what if the player had money? Well, let's add it like has money, but this is bigger, like it has 1, for instance. And let's say that for the action to be enabled, he just has to have more than 0 money, because he can actually offer anything, right? So let's go to the simulator again, and here we see Charlie performing the offer option, right? But now the player is also able to offer something. However, this doesn't make sense, right? Charlie is giving something to the player, and the player is giving something to himself, not to Charlie. So it doesn't really make sense to have this target here, this manually placed. And the cool thing is that we can do like the other rules, where we can have a variable here. And if you remember from what I was saying before, we not only do we have composed names, we also have variables, right? And they need to be in square brackets. Okay, so let's do that. Instead of player, I have the target within square brackets, okay? And now I want to say something, and I want to say that the target cannot be myself. Okay. However, so these conditions are evaluated according to the player's knowledge base, right? That makes sense. So the player is going to evaluate if he has money or not. And the self keyword is reserved for his own name. So when the character is evaluating these conditions, everything that says self is replaced by its own name, so that he knows, okay, so it's talking about myself. However, this is not enough, and we can use this. Not only do we have keywords specific that represent stuff, but we also have, we are able to perform computations here. So we are able to call methods. And one of those methods that we're going to call is the isAgent target equals true. All right. So this isAgent returns if that name or that agent, well, if it actually is an agent, okay? So what happens here is that we have something called the, let me not get lost in time. So essentially the decision making, and most of the rules here in FAtiMA use a unification system to compute the values for each variable, okay? What this means is that we are able to replace, so as we are doing the computation from within each condition, the values that we don't know, so the variables are trying to be replaced by values. And this unification system is pretty good because he's able like almost to check every single value possible for that variable, okay? However, if we give hints to the variables of what they might be, the unification system works much better. So for instance, here, I have an action called insult with the target X, and we say that isAgent X is true, that he actually likes self the targets under 0, so he doesn't like that target, and we need to say that our mode is smaller than 0. But the cool thing about unification system is that when we reach the first condition, he's going to try to replace the X by a value. Because we say isAgent equals true, he needs to replace this by other agents. All right. So he, at the first condition, he replaces X by John, X by Mary, and X by Luke. Say, let's imagine that we have a scenario with these 3 characters. However, when we get to the other condition, we have 3 different branches. He only dislikes Luke, so the unification system is only going to replace the variable X by Luke. Okay. So we know at the end the X means Luke. Okay. And exactly, we are doing something quite similar here, where we have money. Okay, so for now we accept it. There's no variables here, so we don't need to replace anything. But here isAgent is replaced by the player and by Charlie. Okay, so the variable target is replaced by either a player or the Charlie. However, when we get to this last condition, because our name is either, if I'm evaluating as Charlie, self is replaced by Charlie, I know that the variable target cannot be equal to Charlie, therefore it will be always to the player. Okay? Does this make sense? It's something like we're doing here, however the isAgent involves only Charlie and the player, and then when we get to the second condition, or the third condition in this case, it's the one different from him. Okay? Cool. So now let's save and let's see if this works. Okay? So now, if I'm playing as the player, I can only offer stuff to Charlie, right? And that's exactly what happens, okay? So I can only offer stuff to Charlie, and Charlie, let me see, can only offer to the player, of course. Cool. So now we have a basic offer action, right? And we can add other stuff like this. So these methods are not only isAgent, there is a list of them over here. So if you go into the simulator and you go here to the dynamic properties, because this is what we call the computations that we're doing. Essentially, it's something that it's dynamic and that you can try to, can I increase this? Oh, I can't. Oh, I need to change this, sorry. Yeah, sorry guys, I need to update this eventually. But essentially we have all of these variables here. So you can see the mood of the character, you can see the isAgent, you can see the social importance, you can do math operations, so you can add variables, okay? You can do randoms, you can check the volition, which is a CK method. So you can see a lot of different stuff here, okay? And that's the idea. We want you guys to take a look at this and to essentially learn how to use some of them, okay? Strongest emotion, for instance, okay? And so, pretty simple, like we did before. Let's say that you can only offer money if he's in a good mood. So now I can increase this like over, like, I don't know, 2, okay? And the mood is calculated through the OCC system and or the OCC model. So according to its emotions, he might be feeling better or worse, okay? And we can take a look at here. Now, if I start the simulator again, he will not be able to do this action because Charlie is not in a good mood because I told him to start at 0. And we can do something cool here where we can also check for these types of variables here. So I'm asking Charlie, what's your mood? And it's 0. What if I do the same to the player? Well, it's 1.97. Because I told them to start, so the character Charlie starts as 0 and player starts at 2, I can also increase this a little bit just to make it easy on us. So now Charlie, because I said mood self, maybe this is too high. But these values you can change and you can see what it makes sense, okay? And of course, mood is also always decreasing and it tends towards 0. So as I do more ticks, it's going to tend towards 0. As you can see, the mood is constantly decreasing because we have a tendency of getting back to our neutral state. Okay, cool. Okay, so now we have an action of offering stuff, right? It offers money. And let me check the guide because I don't want to get ahead of the guys. So now we have the action offer money is available to X, which is the target. If X is an agent and the agent executing it has money. Okay. So we've just tested it out, right? It works. Both of them have money now, but you know, okay. So now let's take a look at the dialogues. Okay. So let's talk a little bit about dialogue. Okay. So we go over here to the dialogues. And the idea with dialogues is that once again, we can take a look at this. So the idea of the dialogues is that we have a dialogue manager, which is a state machine, okay? However, each of these states, like if I'm in S1, has several different dialogues available, which might go to other states. So S1 doesn't need to go to S2, it might also be to S3. And in each state, there's a dialogue pool, and essentially the characters go like, I want to make an action where my speaking action goes from S1 to S2, just give me and show me it. Or I can go like, oh, I want to do an S1 to S2, but I also want to use the rude tag. So maybe I want to insult someone when I'm going from S1 to S2, okay? So what we have is a mix between dialogue trees and dialogue pools, okay? And so let's take a little look at it. Okay, so first of all, let's take a look at the dialogue. Okay, you can see here the current states. Like there's a start, which goes to the greeting, which goes to another states. Okay, and the cool thing is that we have a tool here called the view graph, and it generates a dialogue tree or a dialogue graph. Essentially, it is able to map out the current dialogue. Okay, cool. So let's add more dialogues to, for instance, the start. So I can do something either like duplicate and then go like, oh, this is a greeting, but say, what up, right? And now I can see that here in the view graph, I have now two different options of going to the same state, right? And over here we have 3 because we have 4 different greetings, right? But only one of them leaves, right? So let's create a new state. Instead of me saying what's up and then going to the greeting, I can just add, once again, this is pretty liberal, so you can add anything that you want, but I can go like, what up state, and I can add it. And then I need to add a new dialogue state called what up. And the next state, I might want to go to the order state. Not much, dudes, something like this. Okay, and I can add it, and now I need to save. Don't forget to save stuff, and then I can take a look at the graph. And now we added this what up state, which just diverges a little bit more. This can create like a lot of different complex trees, which is great, and it's a system that works pretty well if you understand it. Okay. Okay. So we can see here that we have the current state and the next state. So now we know about that. Okay. And now we have these tags here, which are the meaning and the style they essentially are, just like I said, they work as tags. You can put anything here. For instance, I said that I defined in the rules that if he's in a bad mood, he will pick ruder options. And if he's in a good mood, he will pick polite options, okay? Now, something important here is that each utterance is coded as a dialogue action with the following properties: current state, next state, meaning, style, and utterance, okay? However, for the decision, we don't really care for the utterance. So essentially we have the current state, the next state, the meaning, and the style, okay? And this is a special type of action, and this is the only special type of action that occurs in FAtiMA, which is the speak action. So the agents themselves have to decide to do, oh, I'm in the start state, I want to go to the what up state, and I want to use this meaning and this style, okay? And then essentially, the system will calculate which utterance he will speak, okay? So you can see here in the cognitive rules that we have 3 different actions, okay? We have an action with the lowest priority, which is the default speak action. You'll see here that he has speak, CS, current state, NS, next state, mean, meaning, and style from style, okay? And we also have here the speak, but now I've just put rude here because I have the moods. If my mood is lower, then I will select this one. And if my mood is higher, then I will select this one, okay? Now let's go to the conditions, okay? The dialog state with my target will be equal to the current state, okay? What this means is that my dialog state towards this particular target that I want to talk about will start where I am in the beliefs, okay? So he will go to get the current state from the beliefs of the agent. And if you remember before, we saw that in the knowledge base of Charlie, we have the dialog state. So the dialog state towards the player is start. So he knows that he was going to start over here in this start current state, okay? This is something that has floor, is something that we use to determine who is going to speak next, okay? If all of the agents wanted to speak at the same time, it would be a mess, because every single time I ask them to talk, they will talk over one over the other, right? They would be constantly talking over another. So we have introduced this variable called hasFloor. It's no particular variable, it's just defined in the knowledge base of the agent, as you can see here. It essentially points out that whose turn is it to talk. And you can determine this in your scenario, right? And right now, the one who has the floor is Charlie, and the player knows that who has the floor is Charlie, okay? So here in the decisions, when they're trying to go to the decisions of talking, they will only execute this decision if it's their turn to talk, okay? Perfect, straightforward, okay? So now we know that the current state is going to be the dialog state defined in the knowledge base. We know that the one that's going to talk is the one that has the floor, but now we need the rest of the variables, okay? So we need to compute the NS, the meaning, and the style. And for that, we use another dynamic property, just like we had the mood, just like we had his agent, we have this valid dialogue, okay? And the idea of this function is that because I know that the current state is going to be start, he's going to replace the next state variable, the meaning variable, and the style variable by anything it can in the start current state, okay? So essentially this system is going to go over here to the starts, okay? And he's going to replace the next state variable by greeting, by what up, and the meaning by the dash, and the style by the dash. And that's it. And then he's going to return this action. And the system himself, he will decide, oh, okay, he either will do a greeting or he will do a what up, okay? And you'll see here that when I start, this is not good, because so I'm going to disable this one. Can I do this? I don't think so. Whatever. But you'll see that I always have these variables here, and you'll see that if I start to be a bystander, you'll see that Charlie will start to do random actions. He will sometimes say good afternoon, sometimes he will say what up, okay? Because while they're both different actions, they have the same priority, so he's going to randomize it. So he's here, okay? And what I told this system is that if it is possible to execute the roots and if it's possible to execute the root style and the polite style, he will execute these actions with a higher priority. Okay, so if he's able to replace the current state, the next state, the meaning with the polite tag, then he's going to return true, and this action will be highly prioritized over this one. Okay, so because he's in a good state, I know that every time that he's going to get there, he's going to execute the positive dialogue. Okay, so he's going to go for the polite dialogue, as you can see here. He's going to say, how do you do? How can I help you? Or not you again. Or he's going to say, I would like some food, please. However, this is only executed if I do the start greeting. Okay, so let me see. So as Charlie, I need to say good afternoon, right? And how do you do? Good afternoon, how do you do? How do you do? He's always going to pick how do you do because I define him that because the player is in a good mood, he's always going to have a positive mood, right? So he's always going to pick this dialogue with the style tag, okay? Does that make sense? So while we have this dialogue tree and we have all of these 4 different options, I can make some of the options to be more heavily influenced by the moods or by any other thing. I could use social importance, I could use emotions, I could use something in the beliefs, okay? And that's how the dialogue works. We created the new branch of dialogue, which was what we wanted. And we can also, for instance, we could change here the meaning so that he would select sometimes actions with meaning, like he's giving money or something like this. I could associate him offering this to once so I could associate dialogue with if he has money or not, etc. Okay, cool. So we added a few options, and the cool thing here, because I have been kind of avoiding not speaking about the starting kits, but when I press play and I do the exact same thing, or for instance, I select to play as, I believe it was Charlie, I have the 2 options that I created. So I created the word up option. It will instantly go to the game, okay? If everything's working out, it will instantly go to the game, okay? So all of the actions that we do, he's going to say back, not much dude. He's not going to speak because I didn't do text-to-speech, okay? So he's going to kind of break, I guess. Because he doesn't have text-to-speech, but that's fine, okay? Whee! And of course, this script or this project is only prepared to deal with speak actions, okay? Overall in FAtiMA, we don't really care about how you implement this offer action. So in Unity, I didn't really prepare them because it doesn't really mean anything, okay? I offered this, okay? But now, if you were a game designer, you would have to implement this action, okay? Cool, moving on. The next task is the emotional appraisal, okay? So take a look once again, the emotional decision-making component. The final property of the dialogue action style is being affected by the mood of the characters, which is essentially what I told you. And the mood is being affected by the appraisal components, okay? So if we were to start these actions at, so these characters with the mood 0, so let's do them. Let's do that. We have several different ways of even either influencing their mood, okay? And the way to do this is here in the emotional appraisal component, okay? You'll see here that we have asterisks. Every time there's an asterisk means it can be anything, okay? So essentially what I'm saying here is every time myself agent is the target of an action that is a speak, which has whatever meaning, or whatever current state, whatever next state, whatever meaning, but the style polite. I will appraise these variables. I will have an appraisal variable of desirability equals 5, okay? Once again, I'm not going to get into the emotional appraisal component or how the OCC works, but essentially every time there's an event, there's no translation, there's no direct translation to an emotion, but there is a translation to an appraisal variable, which will then generate an emotion, okay? So we can do something like, I have this speak, But I can also do something like, if I wanted, like, let's test the system. If I wanted to do any single speak, anything someone says to me is desirable, then I could do it like this, and I could, maybe 5 is a bit too much, but let's see what happens. So over here, I can go to the player, and the player has the 0 mood, and the Charlie has the 0 mood, and I can go good afternoon. And now the player's mood is 1.5, and his strongest emotion is joy. And I can go here to the player and see, oh, the emotional state is joy. So right now he has an emotion, while at the start he didn't have anything, right? 0. So now I just said that every time I receive a speak action, or I guess a speak action, yeah, then my emotional states will increase. And because player said something to Charlie's emotional state will also happen. But for instance, I can go like, I can play as the player and see that, so Charlie said something to me, and I can take a look at my emotional state, so I'm happy. And however, Charlie is not happy yet. His emotional state is still, I guess, neutral, because I didn't say anything to him. Okay. And this is how the emotional appraisal works. You can also put other stuff here, like the offer gift makes sense that he has a positive, right? I can go like action and offer self. And then every time someone offers me stuff, I can do, actually I should go like this. What happened? Whatever. So I can go, oh, actually I cannot go because I don't have money. Oh, because I'm not in a positive mood yet. So if I'm the player, whatever, you get what I'm saying. So every time I offer something to him, he will get in a great mood, I guess. Cool. So I'm going to change this just to keep essentially checking. Oh yeah, and I can also say this every time I receive an action, and it just works. So every time someone does an action, I'm going to get in a better mood, right? I'm already happy. And of course, Charlie is also going to be ecstatic. So as we go towards, he's going to be even more ecstatic, right? Yay, super joy. And the mood is at 8. So, okay, so this is how the emotional appraisal works. Very simple, very straightforward. You can do complex rules. You can also add conditions which we didn't really add, but these conditions work the same way as the decision making. So you can say that, oh, this increases my desirability if in the knowledge base I don't have money, and etc. etc. Okay, cool. So next part is world model. Okay, so now we have the offer gifts, or the offer, I guess. Let's go number 1. I want to do this. Number 2, I want to remove the stuff. Sorry, my brain is going too fast. So I want to remove the mood so that I can test it. So now if I go like this, oh yeah. So now if I go like this, I have the option to offer. So now let's do something like, so before we had the simulator, or I mean, I guess we had the simulator, but we are not really interested, or we weren't interested in knowing the effects of an action. So like I said before, when you define actions here, other than the speak action, we don't really care about it. Like you can say that Charlie offered me food, or Charlie went and cooked food. We were not really concerned about what really happens, or how do we implement this. However, because the simulator is such a great addition, we need to think about the effects of an action. So in order for you to have a good simulation, we need to know, okay, so when I do this action, these things happen. Okay. So let's try to make an effect or a consequence of this effect for the action offer. Okay. So and for that, to do that, we go to the method of world model. And remember when we talked about the beliefs regarding the dialogue states, this is where they are updated. So every time there's a speak action, once again, I define here variables. So there's the next state variable, the subject variable, and the target variable, okay? And what happens is pretty simple. So every time there's an event where someone speaks to another, someone speaks to another. So one is the target, the one who receives the speak is the target. The one who performed the speak action is the subject, okay? And what I say is that the dialog state of the target agent, so the dialog state regarding the subject is now next state regarding the observer agent, and the one who did that is also gets its dialog state updated, okay? So essentially, if I speak to you, now your dialog state with me is the next state of my dialogue, and my dialog state with you is the next state of my dialogue, okay? So that we are always in the same page, okay? Additionally, I also say that both of our knowledge bases, so both of our has floor variable, okay, of our knowledge bases is pointing towards you because I just spoke to you, okay? Makes sense? So now what we want to do is that we want to add the action offer. So we have offer. We have, for instance, the subject. We can start with something like Charlie and player, and we can give it a priority of 1. Okay. And then we want to add a simple effect, which is the has money property. We want to give it 5, for instance. And we know that it's going to affect the target of the agent, which is player. Okay. So let's do this and see what happens. Okay. Save. I want to play as, I guess, I want to play as Charlie. Oh, I am playing as Charlie. So now let's see. The knowledge base of the agent has money 1. And now I want to offer him money. And let's see what happens. The has money property increased. And now it's now 5. Okay. However, once again, this is quite limited. And this is really almost hard-coded. We can do something quite more elegant where we don't define the subject like this. We define it as a variable. And then we define it as another variable to target. Okay. And what we say is that every time this action happens, while we don't really care for the subject right now, we say that we want this to happen to the agent that suffered this action. Okay, target. Okay, cool. So we go to the target and we say, look, now you have a has money property and its value is 5. All right, perfect. So what happens is that, I guess you won't see it, but let's try to do like, so instead of, actually, let's say like instead of has money 5, let's do something like 3, so that it's distinguished, okay? So now, if I'm playing as, for instance, the player, now I have 1 money. Oh, because he didn't offer me, so let's see if he offers me money. So now he offers me money, so now I have 3 money, and now I can also offer to Charlie, and Charlie now has 3 money as well, okay? So essentially we are replacing the previous value, okay? So better than replacing is using another dynamic property which allows us to make calculations, okay? So we can go once again here to the simulator, and I know this is a weird place to put it, but essentially we can go to math, okay? And we have this variable x, this variable y, and the OP, which is the operation. And you can see here that I think applies the mathematical OP to x and y and return the result. The OP can be, can be either plus, minus, times, or div. Okay, cool. So what do we want to do? Pretty simple. We want a new value to be math. Okay. Now I want to have has money. Okay. We want a plus, and we want, let's say, 5. Okay. Perfect. Okay, let's update it. Hopefully that works. Okay. So let's test this. And so Charlie performs the player offer. So I should have more. So I should have added 5, and I did. And now I offer to the Charlie, and Charlie goes like, now you have 10. So now Charlie has 10. So now we have this. We're getting rich together. So we have a way to essentially add stuff to the variables and to the knowledge base, and we have a way to compute the effects. Okay, and this once again works just like the action rules, where we have different priorities and targets, and while we don't have conditions, we have effects. However, these effects are able to reach the knowledge base of the agent, okay? And for instance, right now, you could do something like, we don't really care for the subject, so we can do something like this, because we are not really interested in the subject, so we don't need to go and look for it, okay? We could even do something where we have an offer, and we store the value that we want to offer here, and we could use a variable here like value, right? Something like this. And then over here, when I was adding, instead of 5, I would have the value here, right? Make sense? So I would define here that my offer would be like 10. Let's see if this works. And it does. Oh, my camera stopped recording. Awkward. So I'll just remove. Okay, I'm here. No. Hello, camera. Whatever. I'm almost done. So I get. Okay, good. We're here. So I guess this kind of broke this. Okay, so we have essentially most of the. I mean, I guess we have the guide done. You've seen the solutions. So my camera is essentially just trying. I don't know. But what I wanted to say is that we looked at most of these components. Okay. Once again, you can use this starter kit to make your own project or to make your own Unity game using these intelligent characters. You don't need to use these models. You can replace them. However, the code is pretty well documented, so you can essentially go and look at what I'm doing here, the cycle, so the small cycle essentially. For each RPC, I use the decide method. Each character has a decide method, which will return an action or a list of actions. And this list of actions is ordered by their priority level. So if they all have the same priority level, it will be shuffled, okay? So essentially, if my decision is different than null, then I execute this decision, right? Or in this case, we are only prepared to deal with the dialogue, okay? So that's why if you have the offer action enabled, it's kind of going to break Unity, but you can just avoid it, okay? All right, finally, what I want to say is that we only looked at like really small portions of each component. They are way more complex and you can do way more interesting stuff. We have some guides here. We also have an extended paper that you can take a look at it. We have here the meta beliefs, and I believe that you have a list full of meta beliefs here in the website. Yes, and we have some examples on how to use them. Okay, and that's mainly it that I wanted to say. So keep at the remember the site, remember to use it. There's a lot of tutorials and lots of videos of me doing complex examples, such as, let me see if I can find them. Video tutorials. So it's not only a tutorial, but we have me doing like trying to implement a story, like for instance a robbery story, and then I have here a fairy tale story. And I do here stuff that's quite complex, and while you don't see my face, you see me writing my thought process, okay? Although this, I don't really like. So FAtiMA-Toolkit, this new version is already the one you're using, so it doesn't really matter. Don't use these links, use the ones here on the Get Started page, okay? And that's it. Thank you for watching. Hopefully you're doing great and you're liking this toolkit. It's pretty powerful, and if you have any doubt, you know where to reach me. There's like a form that you can reach me, or I think you just Google my email. It's manuel.m.guimarães@tecnico.ulisboa.pt. So if you want to reach me out there, you can do it, and see you, and thank you for watching.